Alright, so hello and welcome. We got another question here. This is trips and users hard and LeetCode. We're going to use C++. Let's try to get it going. Here we go. I'd like to take a few seconds just to make sure my setup is working, which I think it is. So let's open that in a new tab. Let's take a look. How many more do we have? 1, 2, 3, 4. 4 more for... Oh, this is SQL. Ooh, I didn't realize that. Okay. All right, so we get some more SQL practice, which I do need more of, which is not going to be C++, but this is going to be MySQL. I've been learning more about MySQL than I care to know in the past few days, quite frankly, but employers seem really interested in testing MySQL, so it is. All right. Trips, table of trips. ID is the primary key for this table. The table holds all taxi trips. Each trip has a unique ID, while client ID and driver ID are foreign keys. The user's ID at the user's table. Status is an enum type of completed, canceled by driver, canceled by client. All right, let's get enum, int, and date. Okay. ID, client ID, driver ID, city ID, status, request at. Users, the user's ID is the primary key for this table. The table holds all users. Each user has a unique user's ID, and role is an enum type of client, driver, partner. Band is an enum type of yes, no. Band. Oof. Of all those things, of all the data you need to have about your users, the most important is whether or not they're banned. Top 3 pieces of data. Are they banned? That's a this is what we care about, all right? Our data, the users' data. Oh, that's hysterical. Cancellation rate is computed by dividing the number of canceled by client or driver requests with unbanned users by the total number of requests with unbanned users on that day. Write an SQL query to find the cancellation rate of requests with unbanned users, both client and driver, must not be banned each day between. That's really funny. They're both banned. Is this a question from Uber? Is that what this is? I'm just imagining, how do you ban your employees? Like, he wasn't a very good employee. Not only did we fire him, we also banned him. Seems like very specific to his particular type of company. Okay, all right. Anyway, round cancellation rate to 2 decimal points. How do you do that in NISC? I don't know how to do that. I guess we're gonna find out. We're gonna learn. We're gonna learn. Turn the result table in any order. Query result format is in the following example. Okay. Oh, whoa. That's not pretty. Okay. Input, trips, users table, output, cancellation rate day. I'm tempted to put this in an SQL fiddle, and that way I could tinker with it. Excuse me. Maybe I could do it without doing that. Explanations. Okay. Explanations. So what is going on? So these are the days there were requests. So we're going to do this on a per day basis. So probably correlated queries, subqueries, what we're going to do. We're going to look to do, and then okay, we want dividing the number of canceled requests with unbanned users by the total number of requests with unbanned users. So all the cancels and requests that have banned users, we basically want to ignore. That's one thing. And the other thing is we also want to know, how are we doing on time here? 4 minutes. We want to know the requests that were not from banned, so no requests if there's a banned user or not. And I think we really we only need the not canceled, completed, where the user it's completed and not banned. User's not banned and the status is completed. But if the driver is banned but it's completed, is that possible? Let's say 2 is banned as a user client. Well, there's no drivers that are banned, but I think it's possible to have a completed. Is it possible to have a completed request? Is it possible to have a completed request? That's really confusing. My guess is that there's a way to. How many times do people get this wrong? I think it's only hard because it's like not really well articulated. The problem is that if the driver is banned, but you have a completed request, that's not supposed to go into the calculation. So we want to count. So what you can do is you could just take you could join the driver ID with the users table, where the user ID is equal to the driver ID, and the client ID with the user ID, where the ID is. Also, another question is like, do you have to check the role as well? Like, do you have like, there's some things I guess you have to worry about or not worry about, but I guess you could just do. You just need to check whether or not they're banned. That's really all you care about. So you can take the trips table and join on the client ID and join on the driver ID with the users table, and join with this twice basically. And do I want to do it that way? Yeah, well, you want to get the driver, whether or not the driver is banned and whether or not the client's banned. That's really all you want. So you would join the trips table with the users table where the user's not banned. I think you do it that way. You just say client ID. So the tricky thing about that though is you want the driver ID and the client ID. So I think you would join it once on the client ID where they're not banned, and then also join again on the users table with the driver ID, where the driver ID matches the user ID, and also not banned. Maybe just two joins on the users table, right? Users X and Y, and X is we're going to match the client ID with the user's ID, and the driver's ID with the user's ID, and from this first table, right, is the user's ID for the client ID, and the second table is the driver's ID with the user's ID from the second table, second user's table, and then also where both of those are not banned, right? Banned is no for both of those. So we could do a double join on that. And then we can filter again in the where clause as well, where the status of this trips table is completed. And then we can take that subquery, or take that as a subquery, like that's a table. So that gives us everything that's completed, where neither users are banned. And then we can say from that table, from the double joins, we want for each day. So we can use a window function here. There may be another way of doing this. So you don't necessarily need to use a window function, but we're going to think for a moment that we could use a window function, and just for, or we could do a correlated query, right? So we could use this. There's a query, and we're going to select that subquery, select from that table, and we're going to say the subquery is if you match this date, right? This request at matches. So I guess you'd have a subquery on the same table. So you create that table as a subquery. I'm trying to think. So you can use that to use a correlated subquery on that same table, which is the double join. And if the request at matches the original table's request at, right, then we can count. So we can use a where these match each other. Maybe I should dump this into a fiddle. It's kind of hard to think about. Pretty much you want to count. I mean, you can also use a window function, I think, and just aggregate partition on the request at dates. And then once you do that, then you can easily just count and divide by how many unbanned users are there? Unbanned requests in total, one of which was canceled. Oh, excuse me. So actually, you can get the double join or get the three tables joined to get. You actually don't want the completed, so you want the total completed divided by the total canceled on that table for each day. So you would count. Sorry, the total, not completed and canceled, just the total altogether divided by. So you can just do 2 counts, right? There's also another issue of like how do I get the decimal point? 2 decimal points. We'll come back to that. But how do I? Yeah, we're gonna use division. We want these to be floats. You can take that you could partition over the count. Take that window function. Actually, I think you can group by. I think that even works. That works too. If you just group by, and you just say count of one divided by count of the other. Can you do that? I mean, you can. Maybe you can. You can maybe. How would you do this? I don't know, man. Dude, SQL is so obnoxious. So much going on. It's so annoying. There's so many pieces to it. What you could maybe do is, so what do you want to do? You want to get the, so we can create a table of just like the requests that weren't from banned users. We can start with that, and we can count. Now, we can count all of those, but we actually want to count them per day. So you can group and count by the date. That works fine. And then you get a sort of a sub table, I guess, which is like the total requests. And then you can have another sub table, I guess, which would be, I guess you could join these 2 tables. So you could do it that way. So you can create these 2 subtables. One of them is all the requests that were made that day that weren't, counting all the requests that were made that day that weren't saying all the requests that weren't by banned users, and then the other one is all the requests that were canceled that weren't by banned users, right? Those tables will be very similar to each other. You could join those 2, and then now you can select from that joined table, and I guess you would just join on the date. Yeah, just join on the date. So you can use group by, join on the date. You're going to use a count for the aggregate, right? And then finally, you can select from that table. You could take the division. Can you do that? Can you do like A divided by B, something like that? If you just said like select from the trips table, and we left join with trips, or just join, or say A and B, select from trips A, trips B, on, we'll just say client ID, and A.client ID equals B.client ID, and then we're going to say from this select from the sub query here. Can we? Yeah, we can. After we join these, we could say A. So we'll do A dot ID and B dot driver ID, something like this. All right, what does this do? How are we doing on time? 16 minutes. As C. We'll just say C. It's fine. It's kind of complicated what I came up with. I think I have a solution, but it's okay. So can we take just say as alpha and as beta, right? Or alpha beta. Oh, didn't mean to do that. There might be a better way of doing this as well. It's alpha beta. All right, so we can do alpha divided by beta. How about that? As alpha beta gamma, I think. I forget what the third letter in the Greek is. Okay, so it does work like that. Okay, we can do what we want. How do we truncate two decimal places? Let's go to the reference, see if we can. We want to go to 5 point, so it's mathematical functions. Okay, and we want to go to 5.6, so 12.6. What are we looking for here? Not statements. Mathematical functions. Oh, this is 12. Okay, this is what we're looking for. We're looking for built-in function operator reference. Yeah. Division operator. Okay. So how do we? Well, that's good, but how do we? You know what we should do? We should actually go to data types. That's probably where we're going to go. Okay. Decimal numeric type store exact numeric data values. These types are used when it's important to preserve exact precision. For example, monetary data. In MySQL, numeric is implemented as decimal, so the following remarks about decimal apply equally to numeric. Okay. This type MySQL stores decimal value in binary format. See 1221 precision math. Decimal column declaration. In a decimal column declaration, the precision and scale can and usually is specified. For example, salary decimal 52. So the precision and scale. Okay, interesting. This example 5 is precision and 2 is the scale. The precision represents the number of significant digits that are stored for values. And the scale represents the number of digits that can be stored following the decimal point. Interesting. Standard SQL requires that decimal 5.2 be able to store any value with 5 digits and 2 decimals, so values that can be stored in the salary column range from negative 999.99 to 999.99. Standard SQL, the syntax decimal M is equivalent to decimal M0. Similarly, the syntax decimal is equivalent to decimal M0, where the implementation is permitted to decide the value of M. MySQL supports both these variant forms of decimal syntax. The default value of M is 10. Okay, so 10 precision means significant digits that are stored. Scale represents the number of digits that can be stored following the decimal point. Interesting. Oh, I see. So, okay, so the significant, that's kind of interesting. So it's, you take the difference between the two to get the, and it's both positive and negative. So the difference between the two raised to the power of 10 is sort of the range, and the second one is the decimal points available. So here 5 minus 2 is 3, 10 to the third is 1,000, so you have negative 1,000 to 1,000, not including 1,000, by the way. It's one less than that. And then it's also all up with 2 decimal places following. So this is really interesting. This is, it's not floating point, it's fixed point. Numeric decimal is fixed point. Yeah, this is kind of interesting. Fixed point and floating point are special. They're different. They're different. So, okay. Interesting. That's why they're specified this way. Standard SQL, the syntax is equivalent to decimal. Similarly, the syntax decimal is equivalent to decimal M0, where the implementation is permitted to decide the value of M. MySQL supports both these variant forms of decimal syntax. The default value of M is 10. The scale is 0. Decimal values can contain no decimal point or fractional part. The maximum number of digits for decimal is 65, but the actual range for a given decimal column can be constrained by the precision or scale for a given column. Maximum number of digits for decimal is 65, but the actual range for a given decimal column can be constrained by the precision or scale for a given column. Maximum number of digits is 65. Okay, actual range can be constrained by the precision or scale for a given column. Okay, interesting. When such a column is assigned a value with more digits following the decimal point than are permitted by the specified scale, the value is converted to that scale. The precise behavior is operating system specific, but generally the effect is truncation of the permissible number of digits. Fair enough. So I guess decimal and numeric are numeric is implemented as decimal, so they're the same in MySQL. Okay. Floating point arithmetic approximate value float double represents approximate numeric data values. MySQL uses 4 bytes for single precision values and 8 bytes for double precision values. For float, the SQL standard permits an optional specification of the precision, but not the range of the exponent in bits following the keyword float in parentheses. That is float p. MySQL also supports the optional precision specification, but the precision value in float p is used only to determine storage size. A precision from 0 to 23 results in a 4-byte single precision float column. A precision from 24 to 53 results in an 8-byte double precision double column. Okay. Permits a non-standard syntax, float MD or real MD or double precision MD. Here MD means the values can be stored with up to M digits in total, of which D digits may be after the decimal point. For example, a column defined as float 74 looks like negative 999.999 when displayed. MySQL performs rounding when storing values, so if you insert this, then the column will result in this. Okay. So 74 is the 7 digits and 4 in the decimal place. It's very similar to the decimal or numeric syntax. And SQL standard permits an optional specification of the precision, but not the range of the exponent in bits following the keyword float in parentheses, that is float p. MySQL also supports this optional precision specification, but the precision value in float p is used only to determine storage size. Precision from 0 to 23 results in a 4-byte single precision float column. Okay, that's interesting. So it just tells you the number of bits, I guess. 8 bytes. 8 bytes is, a byte is 8 bits, so that's 64 bits. I think it's the mantissa and the, yeah, there's a mantissa and an exponent with floating point and double point precision. And I forget, I think there's some calculation to figure out the, how much is in the mantissa, how much is in the exponent. Okay. I don't know too much about floating point, but oh. Fixed point's kind of interesting, but we're looking for so this is floating point and this is double precision floating point. Yeah, this is the mantissa, and this is the exponent. Number of bits in the exponent, number of bits in the mantissa. Where they came up with those numbers, I think it's just from the, right, there you go. So it's 23 bits, right, for the mantissa, and excuse me, I think they call that the fractional part, right? The mantissa is the fractional part. So the precision is 24 bits, 23 fraction bits, but it's 24 bits of precision. And there's an implicit leading bit, right? Okay. Which has to do with like how you set up floating point. It's kind of a tricky thing. Spent some time trying to figure it out or learn about it, but I kind of didn't fully understand. There's such a thing as underflow, subnormal values. They call them, not underflow, subnormal, which is where this implicit bit comes from, which is confusing, but it's a whole thing to learn about, I guess. So regular floating point has 23 bits for the fraction and 8 bits for the exponent, and then there's a sign bit. And the double point is 52 bits for the fraction, 11 bits for the exponent. Now, how they divide up the exponent and the fraction, I think it's somewhat arbitrary how they picked it. Excuse me. And what they call subnormal is if all of the exponents are 0. If everything's all zeros, then you're dealing with what they call subnormal numbers. Exponent zeros, then it gets interesting. So and you take E minus, right? So it's tired precision numbers described by E minus 1023. So that way you get the exponent range is both negative and positive, right? So this is this number, you just subtract 1023 from it, and then the fraction part is just 1 point, and then you just dump the fraction part, convert it to an integer, convert it to digits, I guess. When E is 0, then you get these called subnormals. The fraction is slightly different. because it doesn't have a 1 in front. 1 point times 1 point, it's 0 point, this fraction, which is not so obvious what's going on here. Also, it's not so obvious. Basically, your fraction is just pushed all the way to the side. Yeah, so that's subnormals with precision and all that. But how many bits there are, I think is just standard specific. How many there would be in the fraction and how many would be in the exponent. And then these are approximate, not exact. When you try to use comparisons, you have issues, subject to platform implementation dependencies. More information on that. Maximum portability, code requiring storage for approximate numeric data values should use float or double precision with no specification of precision or number of digits. So what we're looking for though is displaying the data. That's what we want. How do we specify how it's going to be displayed? Maybe in the glossary we can find something. So we just say display. LSN log sequence number. Arbitrary ever-increasing value represents a point in time corresponding to operations recorded in the redo log. Oh, that's interesting. I don't know what that is. What's a redo log? Point in time is regardless of transaction boundaries. It can fall in the middle of one or more transactions. It is used internally by InnoDB during crash recovery and for managing the buffer pool. Prior to MySQL 5.6.3, LSN was a 4-byte unsigned integer. The LSN became an 8-byte unsigned integer in MySQL 5.6.3 when the redo log file size limit increased from 4 gigabytes to 512 gigabytes as additional bytes were required to store extra size information. Applications built on MySQL 5.6.3 or later that use LSN values should use 64-bit rather than 32-bit variables to store and compare LSN values. In the MySQL Enterprise Backup product, you can specify an LSN to represent the point in time from which to take an incremental backup. Oh, that's interesting. The relevant LSN is displayed by the output of the MySQL backup command. Once you have the LSN corresponding to the time of a full backup, you can specify the value to take a subsequent incremental backup whose output contains another LSN for the next incremental backup. Also see also buffer pool, crash recovery, incremental backup, MySQL Enterprise backup, redo log, transaction. Oh, that's interesting. So it just saves everything that happened. Is this the only time display is shown in the entirety of this glossary? Oh, okay. Maybe we could just say, what did they say in the question? They said they wanted 2 decimal points. So round, that's what we want. Round. Huh. Actually, there's a round function, I think, that we can use. That would help here. So we're going to round to 2. I think we got it, if this works. Oh. No. Interesting, so that'll round to 2. All right, Great. That's all we need. All right. So we have this table. It's going to be, we're going to create this table twice with a double join, and then we're going to use it, use a group by and an aggregate, and then we're going to join those two tables, and then we're going to select from that joined table. So we're going to have join with trips of A on, so we're going to say select trips, select from trips. And we actually only really need the count. We can group by. Let's say requests. Request at. And we're going to join trips A on, so we'll do A, B, it's going to be users. We're going to say a.client ID equals b dot users ID. Join users C on a dot driver ID equals c dot driver ID. Where can we just group by the a.request at? I don't know how we do that. How does group by work again? I don't know. I think you just specify a column. Join B, join C, where A is not banned and B is not banned. So we would say banned is no. So we want to say B.banned equals no, and oops, and C.banned equals no. All right, what does this do? Unknown column, C.driver ID, and on clause. Oh. Oh, it works. Hey, look at that. Wow. We're going to say total requests, and then we're going to have the same we're going to call that as alpha, as beta, as beta, as beta. Left join, we're going to join on join, alpha beta on, alpha dot request at equals beta dot request at, and the second we're going to select from these, and we're going to say the second one is not total requests anymore, and they're not, oh yeah, we're going to have banned users, and so these ones are the total, so these ones at the bottom are the total requests from not banned users, and this is total canceled. requests. Ah, and this is going to be end a.status. Now we're saying they want the number canceled. Okay, and divide by the number that are canceled. A.status is equal to cancel, or is not equal to. You could say not A.status equals completed. That might be easier. All right. So this is total canceled requests. And we're going to say select round by 2 decimal places, the total canceled requests from the divided by total requests. Now, we might end up dividing by 0 here. This could be kind of a problem, huh? Uh-oh. 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 Well, the total requests can't be 0 if, or yeah, total requests could be 0. What if there are no requests that day? Well, if there are no requests that day, or what if all the requests made that day were by banned users? Then what? Then what? Then you'd have 0, right? Uh-oh. Uh-oh. What if it's 0? Uh-oh. This is pretty close. I don't know if this is it. Is this it? What does this give us? Oh yeah, okay. Close. 0.33, 0.0. We're missing cancellation rate. And then we're gonna have the day is, let's say request at, and we can write that as the day. Something like this. Oh. Oh, I see. Is that the issue? Can I do this? Alpha from the subtables? Oh, it worked. Okay. Why do we not get 2? Oh, because there weren't any that matched this not status completed. Like all of the canceled requests were. Oh, that's interesting. So, what happens if you do a left join? Oh, that's interesting. So there weren't any. That's close, but there weren't any. Excuse me. You couldn't join this table with this table because this one. So I think we could do a left join on these two tables. What does that give us? Let's do this. Can we do this? Just throw an inline, multi-line comment in there. Does that work? Okay. Maybe I should be using a fiddle for this to manipulate it. Cancel requests, request at, total requests, request at, values 101, 301, 3, 3. So that's really interesting. Maybe this doesn't need to be a left join. Maybe this one is fine, but I think it's this one could be a left join. So the total requests is not a big deal, but well, yeah, maybe actually we should go the other way. Maybe we can do a right join then. I'm not sure what's going to happen. What happens if we get a right join? All right, null, null. There we go. That's what we're looking for. Now, if we take these two, now the reason we're taking a right join is so when we have a null, but we might not be able to divide by or multiply by a null. Oh, there we go. It's just null, null. Okay. We just replace null with 0. We can use an if statement here. I think that's fine. But what's weird is it's actually kind of strange. What? Wait a second, wait a second. What is going on here? So the problem is that we're taking alpha request. We want to take whichever one is. So the total should be beta request then. Actually, that's probably why. So take beta request. That won't be null on the right side, right? But the division will be null, right? Still. Now we can use 0 instead of null. Yeah. So this would be sort of a function here. This is going to be interesting. Total cancel request. So we can use an if. This is null. Then return 0. Otherwise return total canceled requests. Oh boy, this is involved. What? How about built-in? Is there an if function somewhere in here? If else construct. Oh, there's an if null. That's probably what we want. Ah, I see. Okay. And what we want to do is, oh, there you go. I think just if, oh, you can do 1 divided by 0. Oh, that's even better. So we would say if null, zero, otherwise returns expression 1. That's what we want. If null, around that 2. That's more or less what we're looking for. Something like this. Hey, okay. Now the total requests, if there's any requests, the total requests it'll exist, but the cancel requests could be empty. It feels like I need to have a few different test cases for this though, for me to be comfortable, but it would take so much time to go through the test cases. I don't know, man. I'm tempted to there's definitely some test cases here that could cause issues. We just go for it. I think we just go for it. I don't know. It's probably something wrong. Very likely something wrong. I don't want to look at it. Yeah, of course. There's always something wrong. It's just, there's so many cases, you know? There's so many, it's like, takes so much time to go through all the cases. That's only one example. Oh. Alright, what's the... Is that just laziness? I don't know. I don't know if it's laziness with SQL, where it just, there's so many pieces to it, and it's just so much extra effort to go through all the parts. So I got the wrong answer for this. Maybe it is laziness. I don't know. I don't know what to say. No excuse. So cancellation rate was 1. So what are they expecting here? What? So there was one request canceled by the client. Neither of them were banned. And this is a 0, not a 1. Cancellation rate of requests with unbanned users each day. Oh, brother. Come on. What? You gotta be kidding me. The reason why we exclude this is because it's in this date range? Oh, that's lame. Oh, what? What? I didn't even see that. I'm so sad now. That's obnoxious. and oops. There's all these conditions. So end, the date, so request stat. You could do this at the end. actually. It's a little more efficient to do it in the beginning. It's kind of duplicated here, but you could just say request at is greater than this date, and it's going to be a.request at, right? Yeah. And this has to be as a date, I think. I don't know how that works. And a.request at is less than or equal to same date. I'm so annoyed. I'm upset. I'm upset. So it's got to be in this range. Brother. Brother. I didn't even notice that. I guess I should have noticed that. I don't know. It's not like... I guess I should just reread the question before I submit. Oh, it works. Wow. Okay. There's almost certainly something that I missed here. I'm going to go for it. I'm going to go for it. Hey! Didn't miss anything. We got it. Hey! Oh! Oh! Alright, that's kind of on the easier side, actually. The only issues that I had were, one, this part. So I didn't know the rounding and the if null offhand. I did have a good sense of the joins though, like what to join to make it work. Joins were okay, the rounding was awkward. The rounding I didn't know. If null I didn't realize either, but that helps a lot. Especially because it divide by 0 just automatically, just if null, done. Don't even worry about it. And then I totally missed this. I flunked that. I didn't realize. I was like, oh, herp derp derp, you know, just get what they're looking for. And nope, they wanted very specific dates. Like, okay. All right. So I missed on that, but we did okay. We did under an hour. Not too bad. Yeah. Overall, I think I was pretty good on this. Yeah, the right join helped a lot when you had things that are null. The total requests would pretty much always have, would sort of always never be null. So maybe this should have been on the left side then, but either way, yeah, that worked out nicely. That was pretty simple. Just a bunch of joins. Just a bunch of joins. Works out okay, not too complicated. So yeah, not bad. All right, I mean, you know, like submission rate is so low. Oh, there we go. Hey, 90%. Just randomly rolled 90%. Sweet. I don't know. Just submit a few more times just to pad my score. It's probably not a good idea to do that, but 1, 2, 3, 4, 5, 6. Get ourselves up to at least 80%, right? Well, at least 80% on the hards. Let's see, if you do one more, you get 1/6 is still like 80. Can you get to 90? You have to do it. You have to submit it 9 times to get 90%. Let's see, 1, 2, 3, 4, 5. Wait a couple seconds. 5 out of 6. Yeah, 6th is like 16%, a little less than that, 14%. What's a 6th? No. Yeah, it's like 15%, 16%. It's around there between 15 and 16. If you go to 7, it's like 14%. And then if you go to, oh wow. And if you go 1, 2, 3, 4, 5, 6. How many do we get? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 is like 12%. So we're still, yeah, you have to submit it 9 times to get 90% every time you get it wrong. That's brutal. Dude, that's rough. I think there are situations where I just like I pad the heck out of my score and I just submit it like 30 times. All right, we can do one more, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. How we get 90%? We feel better about ourselves. At one time you get it wrong. At one time you get it wrong. It's so costly. And what did we do wrong? Yeah, I didn't test like data. I just didn't do any tests because I don't want to go through the trouble of writing out all the data. It's kind of a lot. Yeah, it's probably laziness. I think it's fair to say. It's kind of lazy. Maybe next time I'll do that. Yeah, I guess now knowing that you have to submit it 9 times to get that 90% just because you submitted one wrong. I think I'll go ahead and I think I'll go ahead and I think I'll go ahead and go through the trouble of building a table next time. Yeah, I just totally missed that. I mean, more importantly is to read the question again before you submit it. Just read it one more time to see if there's anything carefully, see if there's anything you missed. Interesting question. All right, I'm gonna go. So thanks for watching. That was about an hour. I think I could have done that a lot faster if I had a better sense of things. I just need to know like the if, null, and the round, and I guess just generally more familiar with like SQL syntax and things. But yeah, thanks for watching. Talk to you soon. Have a good rest of your day. And we'll pick up another one shortly. I don't know what I'm going to do exactly. Probably take a small break and then maybe pick up another problem.